So if you've got a good, if you've got a good geometry optimization calculation, then to restart it with just the frequency calculation, this is all you need. Can I get you to the third switch? You'll hit the third switch. Yeah, that's better so that you can see. Okay, so you know, at the very beginning, you have this percent. So if you open a text file to create a new input file, you can do this with Notepad. So let me just show you where that is. It's very simple to do nowadays in Windows. So let's go back here. So you just come over here and click on the Start menu and just type in Notepad. And it's searching. So whenever you type in, you can even do that with Gauss View and so on. You just start typing and it'll look through all of its programs and say, oh, here's one that matches. So here's Notepad. Hit enter. And you get this text editor. So it's a small text editor. It doesn't have any formatting or anything. All it will do is show ASCII text, and it can word wrap, like it can, you know, but it doesn't have any margins or anything like that. It's just a text editor, but it's super useful. And so this is, let's see if I can make it big. No. So what you can type in this Notepad is, let's say we did a calculation on a geometry optimization on water. And so we had opt on water. And so then we had water.chk and water.log. Okay, and so the CHK contains the geometry. The CHK contains the geometry, and the log contains the optimized geometry as well. Okay, but this CHK file is called the checkpoint file. That's also the file that you would use to make surfaces. So electrostatic potential surface, electron density surface, and so on. This checkpoint file is really a useful thing. And so you could put up here, you could specify its name. So water, let's see, you do CHK is equal to water.chk. And so in this Gaussian calculation that I'm going to run next, I specify the checkpoint file. Okay. Then I have a blank space. That's important. Let's see, is there a blank space between the percent card and the route card? I don't think so. Okay, so the next one is then this $sign, hashtag nowadays. Okay, the route card. This tells you what kind of calculation you're going to do. And so you don't need Gauss View, really. The only reason you need Gauss View is to build the molecules. Okay. Once you've got the molecule built, then you can do a lot of these calculations just using the text editor. Okay. So here you have %K. You could do B3LYP /6-31GD. Okay. And I'm running out of space, so I'm going to go ahead and erase these. So you've given it the level of theory and the basis set. So you type that right in after the route card. And then it needs to know what kind of calculation you're going to do. So you type in freak. Okay. And these can be in any order. It's really nice with Gaussian. It has pretty much open input. If you freak first, it finds it. If it's last, it finds it. But this is the important piece right here. Geom equals check. That's how you avoid having to write out all of your molecular structure. So if you have an optimization that's successfully completed and you want to do a frequency calculation on that, or if they could say you even wanted to up the level of theory or shrink it down, you can just do a different frequency calculation using the same geometry by pulling the geometry from the checkpoint file. So this checkpoint file has to be from a successful optimization, and then you can pull the geometry from that checkpoint file. And that's a really useful tool. Okay. Then you have a space, the title, space, then you have the charge and multiplicity, which is based on the total spin of the molecule. And then no space, you go right into the molecular input. This is where you would put the Z matrix or the Cartesian coordinates. And so if you did not have a successful calculation, but you did have the Cartesian coordinates, you could paste them into here. There's no space between the charge and multiplicity and those coordinates. But if you have this keyword, geom equals check, you just need charge and multiplicity and then you're done. And so this is all you need for a Gaussian input. And so then you would open up the Gaussian calculation engine, Gaussian 03W, and then you could load this file. And if there were any errors or whatever, it'll tell you, and you can actually edit them or change them in the Gaussian program. So let's do that. If you didn't want to use the notepad, let's just go in here and type in Gaussian. Oh, I'm going to use the G that I have. Gaussian 09W. Very slow. Yeah, I probably have. Yeah, you got click disease. Look how many I have open. Wow. Okay, that was the last one. Let's try this again. Okay, so here we have our Gaussian window, and I can do File, New, and here's our different sections. And so you can edit it right here too. You can start with percent, or you can say percent CHK equals water dot CHK. You don't have to do this one on your spreadsheet or on your laptop because I don't think you'll have a water dot CHK. But then here you can do the hashtag and then type in your root card, title, charge and multiplicity, and then you leave the molecule specification section empty if you have geom equals check. Yeah. Now, one thing is cool about this too. Let's try this. I'm going to type in HF still 3G just because I want it to be fast if it does go.
Water.
I don't know. I think I do. Okay, so there I have it. Now, this is a cool thing if you're running Gaussian sort of from this command line view. Up here is this little check thing. And what it does is it tries to start the calculation. And if it can understand what you've typed in, then you don't get any errors. And so this is a way to see if it's going to die immediately or if it's going to run. Okay? And so if you have, let's go in and let's make this a bad calculation. I'm going to call this a doublet. So I'm going to say that this is a water with an unpaired electron. But water has an even number of electrons. So it can't have one unpaired electron. It could have two. So it could be a triplet, but it cannot be a doublet. And so I'm going to come up here and click the check box here, and it'll say, oh, that's too bad. Well, the check, I guess, just checks to see if my route card's okay. Let's run this one and we'll see what happens. Yeah. I wish I had a sound effect. Yeah. It's asking me, okay, where do you want me to save the output file? Water. Boom. Severe error message. And so then it automatically loads if you're running it from the command line, the output file. And it cuts down here and it says, structure from the checkpoint file, water, non-existent file. Okay, so I typed in, go get my geometry from water.chk, and it says, I looked, no such file, okay? And so it's gonna look, and you might get this because where did you put your structure, your checkpoint file? If it's not in the scratch directory, then it's not gonna find it. So you may have a checkpoint file, but if you didn't give it the full path name or what have you, then you might have that error. So there's that. I actually had 2 errors in the input file. I had that multiplicity error, but it hit the checkpoint file one first and died. So let's come back to modify. Okay. And so this is just another way to pull in a geometry from a checkpoint file. So that's when you would want to do separate calculations of opt separately than free. Let's look at this. Instead of geom equals check, let's do opt here. So why don't we all go ahead and do this one? So go ahead and pull up Gaussian, not Gauss view, but Gaussian on your computers.
How do you open the existing file job edit box again? Mine was still loading when you did.
I'm sorry, say that again.
How do you open that screen again?
Okay,
It's still loading.
yeah, let me,
Process.
let me exit, okay. So it was under File, New, and then if you have one that you've been working on, you can do Modify, or you can do Open. So I already started one, so I'm doing Modify, and so I have this. So what we'll do is we'll do HF, SO3G, opt. So we're just doing an opt calculation. And then %CHK equals water.chk. And then the charge of multiplicity is 0, 1. Okay? And then I want to do, let's say I want to do a frequency calculation after this, and I didn't know you could do opt plus freq. Okay, let's say I didn't know that, or yes.
Is there a space between 0 and 1?
Yes, a space or a comma, something that separates them. Mm-hmm. Yes. And so then look at this additional steps here. So this additional steps, if you click that, then you get, this is kind of glitchy, but you can see maybe that says step, edit, I don't know what that's. Yeah, check group. So we'll do step and add step. Okay, so this is additional steps. So you can link a bunch of steps together using this method. And so here, notice that it's already filled in the CHK file, the checkpoint file, because that's going to pass the geometry on to all the subsequent steps. Okay. And then in the root card, we do the pound symbol, HF. Let's do some, okay, so now we have HF, instead of SO3G, we're going to do 6 dash, no, let's do 321, 3-21G. So this is to show, if you wanted to have a different basis set for your frequency versus your geometry, you can do that. You can't do that with opt plus freq in Gauss view. So this would be an example of when you'd want to have to do it the hard way. Okay? And then we do freq. But we've got to put in here the geom equals check. I wish I could make it bigger, but I can't. So hopefully you can still see. Yes?
Let's say you have multiple optimized geometries, but they're all different compounds. You should not link those together.
you would do individual frequency calculations for each of those. But yeah, I don't know what do you mean by link them together?
So let's say I have methane and ethane. Like, can I do the frequency calculation for methane and right after do the same thing for ethane? Like, would that be something good to do, or should I just separate?
Okay, there's a different way to do that. What you're talking about, I think, would be a batch calculation. So I'll go ahead and teach you that. So let's say you have 3 or 4 calculations and you want to run these over Saturday and Sunday, right? And you don't want one to die and kill all the others, right? So if you were trying to link them in this job and that job killed or died, all the subsequent steps would die too. They wouldn't go. But a batch calculation is just, you can load up a queue and have your computer calculate as many as it can calculate till you get back. And that's really great. You can run 4 or 5 or however many you want overnight and just add things to the queue, and that computer will just be working its way through all of them. So I'll show you how to do the batch calculations.
A while ago, when you were trying to check to see if there could be a unit error,
Yes?
go put the check route, it does at the top, it does that.
Oh, this check route, yeah. That may be the menu item for this little checkbox. Yeah. Yep, so it at least can understand what I'm asking it to do. And I think it's really just checking the basis set and the frequency, because it didn't check the geom equals check, because then we finally got an error after we ran the whole thing. But
Mine, I did mine, and it told me I didn't have the file.
yeah, oh, it did. Okay, that's good. So here we have now the frequency equals geom equals check. So I'm going to hit OK here, and I'm going to hit run. So this little play button, hit run, and it should ask me to save the file. I'm going to go ahead and go into my Scratch directory and call this test water. And I'm going to call it .log because I like .logs better than outside of the log. Oh, I got a severe error. Oh, at the very beginning, yeah. They're doing an optimization of water and they didn't give it anything. Okay, well, water's small enough, we can do a Z matrix. Okay, so let's do that. We come up here, File, Modify. So we'll do oxygen. This is so easy. Oxygen, okay. Hydrogen, tab, atom 1. Oh, wait, tab. Don't use tab. Jump me into something else. Give it like 3 spaces, atom 1, 3 spaces, 1.1, okay? So that's our hydrogen-oxygen bond link, okay? Hydrogen 2, 2 spaces, bonded to atom 1, at a distance of 1.1, angle with atom 2, 109.5. So there's water. Piece of cake. Okay? So now we're ready to run it. Is everybody with me? Before I hit go, if I hit go, it'll disappear. Okay? Yes, I see nods. Alright, so we'll do that. Go into the Scratch directory and we'll do the test water. Log, we'll actually go overwrite, and we'll say yes. Error? Just faster than me. Up here it says active job. Sometimes that's useful. I think it might say step 1 or 2 or something. Really long for a scope 3D. Because my initial guess was so bad. Yeah, see up here it says additional step 1. So you can kind of see some status on Gaussian. So we're finished with the geometry. Now we're working on the frequency. Yay. Nothing resembles a new phenomenon as much as a mistake. Enrico Fermi.
Mine's
All right, so then I can, this little window up here, the little magnifying glass, that opens the output file. So I can click on that and go to the output file. Okay. Now, how many people have learned the hotkey Ctrl+f? All right, you're trying to find something on a page or web page, Ctrl+f is fantastic. Ctrl+f, you can use this here and do SCF or something like that. And you can get all of the energy, interim energies. Let's say we wanted the enthalpy, so we can look for enthalpy. So there we are, there's the enthalpy and the free energy. So Ctrl+f is very handy, as you might imagine. But wouldn't it be nice if we could do Ctrl+f in kind of a batch way where it shoots through the file and dumps everything it finds out to a text file? All right, think of your frequencies. If you wanted to pull all the vibrational frequencies out, wouldn't it be nice to type in frequency and have it search through the file and dump those into a text file? Okay, let's go back to the 1970s in MS-DOS. Okay, so even though we're way beyond Windows 3.1 and all that stuff, and they still have, instead of what used to be called the DOS prompt, they call it the command prompt or PowerShell. But it still has a lot of the DOS commands, disk operating system commands that were written by Bill Gates. Okay, they're still part of this computer system. So what I'd like for you to do is to go click on the Start menu and type in CMD for command prompt. Hit enter. Okay, I'm going to make mine big so that you can follow along. Can I get a show of hands of users who've used this command prompt? 3 people. Okay, that's good. Yeah. Pardon?
That's many times.
Yeah, okay, so first of all, let's learn how to get around in the command prompt. Okay? So I might write some of these on the board. Let's see. I don't know how to do this. Yeah, I'll just write it on the board. So I don't know if I can come up with 10 of them, but it's like the top 10 list of good commands in the command prompt. Okay, let's try to come up with top 10. Okay, so MS-DOS commands. Number 1, or do we start with 10? I don't know, we'll do number 1. Okay. Number 1, dir. The folders used to be called directories. Okay, the very first killer app that was like a personal computer was used for was names and addresses. Okay, and so you had all these files that had names and addresses in it, and so your folder was not a folder, it was a directory. And so that name stuck. And so if you type in dir, and you can, it's not case sensitive in this case, these are called directories. So even though Windows calls them folders, if you'll notice here, the underneath all of that, it calls them directories. So when you hear me say, oh, you got to give it the path to the correct directory, don't be confused, because I'm just using the old language that I grew up with. Okay, you need a path to the correct folder is the same as you need a path to the correct directory. And so these are all the directories on my account under this particular directory, users/sharing. But let's all go to the same place. If you want to change to a new Yeah, so if you want to change to a new directory, CD, so it's change directory. And then, so number 2, CD, so change directory. And there's some nice little tricks here. I can type in the full path for the directory that I want to go to, and it would go there. Or I can use dots, okay? And so this one, I guess we'll do that as 3. CD ... goes up 1 in the tree. So let's play with that. CD ... Look what happened. Do you see what happened? I was in Darren, and I did CD ... and I went back a step. So I went up in the hierarchy. So your disk drive is got, you know, the C drive, and then you've got the first level directories, and then down and down and down. So it's just a big tree. And when we say CD ... we're going back up 1 level. So CD ... goes up 1 level. And that's very useful. So let's do that again, CD ... So now we're at the C directory, at the root directory for the whole disk drive. If I type in dir, I get the main sort of areas. We've got program files and everything. What do you see? Minecraft, yeah, Minecraft. For me and my son, we play Minecraft together, so that's where all my stuff is. And so then what we want to do is we want to go into the Go9W directory. So CD space G, and then watch this. I don't like to type. Go9W is the only one. Oh, there's a game of Go0. That's the only one that starts with G0. And I hit tab, and it fills in the rest. So tab key, number 4. Let me just code for tab key. Now that seems frivolous to use on Go9W because that's only 4 characters. But if you have a descriptive file name that's 20-something characters long, that tab is your best friend, right? If I'm typing out, give me your compound again. Benzoxazoberol.log. Okay? You should probably not put the unique thing at the end. You should probably put the unique thing at the beginning. So instead of titling all of your files benzoxazoberol number 1, benzoxazoberol number 2, put the number 1 and 2 at front. So you can type in, you know, if you're going to do an action on that, number 1, tab, and it'll fill in the rest. Or number 2, tab, and it'll fill in the rest. Okay, so you want, and it's just to help you if you're going to be using command prompt for anything. Okay, so CD, Go9W, enter. So now we're in this one, dir. Okay, so I've got a lot of calculations in mind. You saw it went past the screen. So let me do that again. Okay, up arrow. We're going to easily hit 10. Okay, 5, up arrow is the history of all of my commands that I did. So I want to do that same command again, the dir, and I could type in dir, which is not too hard to type in. But I could hit up arrow, and you see I see dir as my most recent command that I typed in. If I hit it twice, it goes up. So it's keeping track of everything I've typed in. That's super useful. So up and down arrow lets you cycle through the history of everything you typed in this session. So that's really nice. So I did up arrow directory, it gives it to me again. You see how it ran off the screen? Sometimes you don't want it to run off the screen. And so you want it to give you a page at a time. So if I do dir, and then I use this vertical bar and do more, it gives me a page at a time. See that more down there? I hit the space bar, I get the next page. Space bar, next page. Space bar, next page. So I can go through this whole huge directory one page at a time if I'm trying to find something. What's that?
You did enter each
One line at a time? Yeah, there's lots of things. So there's a lot of features with more, and so you can type in help, space more. And it'll give you all of the features for that command. So help space command, like dir and so on, is a way to get what they call the manual entry for that particular command. So help space, maybe let's type that one in as number 6. Help, and then command, you know. And that will give you help on that command. Now, there's a funny one called less, okay? More lets you go one line at a time and maybe a page at a time, but wouldn't it be nice if you could search through there and like find particular things in that file? And so less has more features than more, because less is greater than more, you know. So the programmers are silly, but that's what you have. Now, let's look for, let's go to the scratch directory. So cd scratch. And so we're in the scratch directory. It has a capital S on it, so that tricked it up. And there's our testwater.log file. Do you see that? Testwater.log? Okay. You know, one thing that would be nice is I remember doing testwater.log, but I don't remember, so this is pretend we've gone several weeks. I don't remember what root cards, like what is that calculation of? Let's just do find. And the root card, that pound sign. So I'm doing find, and in quotes, putting the pound sign, and then test. Okay, so that's testwater.log. Isn't that cool? It gives me both root cards. I know now this is a multi-calculation, and I get both root cards. So I got the opt one, and I got the freq one. And anywhere there's a pound sign in that file, it returns the line.
So fine.
Yeah, fine. Exactly. Number 6.
That's it.
7. Yeah, 7. Find. So search in a file. So this is really super. Okay, if you wanted to see if it, what is the, can you, let's see, we might have it here. Yeah, let's look. So let's look at the very end of the file. And notice it says normal termination of Gaussian. I could look in here and see if this was a failed one. Or let's do the CPU time, so that would be good. So I'll type in find, and in quotes, I'm just going to type in CPU and see what that gives me. And I type in test W and hit tab. Okay. Yeah, and so that tells me the first one I did, find $, told me what the calculations were, and then searching for CPU tells me that they must have completed because I got the CPU statistics out of it. Okay. You could also search for the normal. You can go up arrow, back space with the back arrow, and you can edit this thing. Yes, so that tells me both of them were normal termination of Gaussian. It gives the date and time stamp. So this is really great, a super good tool. Okay. So let's say Matthew had all of these calculations with his energies in his geometry optimization, and he wanted to get all of the energies in like close knit together so he could copy those and paste them into Excel and plot that. Like if you wanted to plot that data of the energies, you could look for SCF. So let's find SCF done. So in quotes, type in capital SCF DONE. And every time it does like a convergence of the wave functions and everything and gets the internal energy for that structure, it produces an SCF done energy, that internal energy, and then it changes the geometry and does it again. So this is the energies of every geometry step. So as it iterates, it goes through these and you get all of these energy steps. And so then there's, in this particular optimization, we were finished in 6 steps, but yours may be much longer. And so this is a way you could somehow get these energies out and into Excel, and you could plot the progress of that. If you wanted to plot the barriers or whatever, you could use this kind of output. But it's not in Excel. So, or in a format that we could use for Excel. This is still just in the command prompt window. So wouldn't it be nice if we could drive it over to Excel or to a text file? So watch this one, okay? I'm going to go up, and then I'm going to hit a space, and I'm going to put a greater than symbol and do test water.txt. So I'm going to take SCF done out of the log file, and I'm going to send the output over to a text file. Somebody follow what we're doing. Instead of displaying it to the screen only, we'll display it to the screen and we'll stick it over into the text file. So this one is another, this is called redirecting. So number 8, greater than and double greater than. So this will redirect our output to a file. And you got to give it a file name. So look what we have up here. We have find SCF done in this log file, and then we have the greater than symbol, testwater.txt. Now, this, if you just have a single greater than, it starts a new text file. If you have 2 of them, it appends to the bottom of that text file. So we might have multiple search terms, and the first one creates a new file, the second one appends to the bottom one. So like an appendix is added to it. So it appends to the bottom of that file. And so let's hit enter. Okay, so it just redirects the output. Instead of sending it to the screen, it sends it to this. So now let's do directory, and we see testwater.txt. If we wanted to just open that in Notepad, we could type in Notepad testwater.txt. And there it is. So, isn't that cool? And now we can take this to Excel and do what's called a text to columns, where you paste it in and then you cut it and you only get the data out. And we'll teach how to do that next, like probably next time. Okay, so some tools in Excel. So redirecting output, we're at 8. Okay, batch files will be number 9. 9, the .bat file. This is how you make a string of these commands that Windows will run in order, okay? So I've taken everything that we've learned and put this in a file. Let's go, let me just find it. Well, I can just open it from in here. So, Notepad. I don't think y'all have this one. This is a file that I wrote using these same commands. And you can, this percent, okay, this rem inside this file is just a remark, okay, so it's not executing this line. But notice I have find route card in file 1 and redirect to file 2. Find CPU job time in file 1, redirect to file 2. Find frequencies in file 1, redirect to file 2. Find Raman activity, find IR intensity, and then more number 2. So that's going to, at the end, show me this file. So I wrote this using the same commands that we have here, but I saved it in a file called parse.bat, and Windows will run .bat files. So if I go over here to my thing, I say parse, test water, .log, testwater.txt. I'm going to say water 2 because I already have one of those. .txt. And so it says this batch file looks up and echoes, means it displays information for the selected molecule. Press enter to continue or any key. And here it has all of that in one thing. And it gives it to me in more so I can hit space and go through it. So here are the frequencies, here's the Raman activities, the IR intensities. And so then if I do notepad,
You press up there.
yeah, let me go to here. Here's what I have in terms of my output file. And so I want you guys to have this skill so that you can easily save time of scrolling through the log files. Or Ctrl+f, that's great, you've got Ctrl+f, but you lose track of where you are in the file. Is that the last geometry or is that the middle geometry? So it really helps sometimes to use some of these tools that are ancient in terms of computing. So let's see, number 10, what would be number 10? I guess notepad the file.
You're supposed to tell us the basis set methods.
One more time?
Was it supposed to show us the basis set methods?
It may be further up.
Oh, is it?
Oh, it doesn't say. Yeah, I don't know. Let's see. Where is the part? Yeah, it didn't pull it. That's strange. Yeah, I'm sure.
You do that.
Oh, there's a space
Yeah,
here. There's a space here. Somebody did give rid of that space.
Run it again.
Hit save and run it again. The up arrow
Twice.
a couple of times. Go. Okay.
There, yeah, I see it.
Notepad. Oh, I meant to do.
There you
That one. Yeah, select folder. Yeah.
I have a question.
Yes.
So on the Gaussian, if your file is not in the stretch file, and stretch directory, how do you run it?
You would have to supply the full path. And so what I typically do is I will use that scratch directory for all my calculations, and then I'll drag them into other folders to kind of organize my work.
usually do it before space folders.
Yeah, so it's probably helpful to, and it's convenient if you have parse tools and things in there to go ahead and work in the scratch folder. Your checkpoint files are going to be in the scratch folder, but then you can drag them out of there and put them other places. You sort of once you've analyzed them. Okay. So I think that's probably time.